There's a gigantic thing that says ACT rooms.
On the main stairs or the main hallway.
Okay.
All right, guys. So let's go ahead and get started. I'm going to give you a head start on me. There's a warm-up. There are 3 A, B, C. So it's a good thing we just went over the homework. And what I want you to do is to condense. So it's one of each of the properties. Mm-hmm. Yeah. Oh, thank you. Yeah.
And then I'll share all the
Mm-hmm.
videos and everything.
Yeah, so you should be able to watch everything. Okay, all right, so here we go. Letter A, if I want to condense, this is the product property, so it's ln xy. Letter B is the quotient property, so it's log 2 over x. And C is the power property. Whoops, this is a 3. So it's log x cubed, that's an x cubed. So, what we're going to do today is we're going to look at logarithmic equations. So, if the equation contains only logarithms, then rewrite so that you have one logarithm on each side of the equation. Then the insides are equal. I strongly recommend before you start your homework today, I want you to reread these notes and sort of like pause after a sentence or after a group of problems and look at what did we do? Why did we do that? What properties or definitions, why did we do what we did? That will really, really help. All right, so one other thing I need to mention before we get started is when we did y equals, let's say, log x base 2, the domain is x greater than 0. So do you remember when I was going over homework and I said to you, planting some seeds for the lesson here, exponential functions have domain all real numbers, so we don't have to check. But in a logarithm, I can't put a negative inside a log because it's impossible to do 2 to the y equals a negative number. Like, there's no y value I can come up with. Think about that. If I do 2 to the negative 1, that's not a negative. 2 to the negative 1 is 1 over 2. Likewise, I can't get 2 to the y to equal 0. So, what you're going to have to do for logarithmic equations is you have to check for extraneous solutions. And I'll explain what that means. But in number 1, I have 1 log equals 1 log. So all you do is set the inside equal. So I'm going to make it 7x plus 3 equals 5x plus 9. I'm going to give you a head start, and I want you to solve that. And what's really neat is, if you reflect back on your math career, do you remember you were doing these kinds of equations in Algebra 1? But you had no idea logarithms were in your future. So you've got to trust your math teachers that when we're doing this, it's because of something you need later. So I'm going to subtract 5x. I get 2x plus 3 equals 9. Subtracting 3, I get 2x is 6, so x is 3. Now, when I say check for extraneous solutions, what we're checking is that the inside of the log is bigger than 0. Not that x is bigger than 0, but the inside. So look, 7 times 3 is 21, plus 3 is 24. That's okay. times 3 is 15. 15 plus 9 is 24. That's positive. That's what I'm checking for. All right, so number 2. 3x plus 5 equals 7x plus 13. So if I subtract 3x from both sides, I get 4x, and if I subtract the 13, I'm getting x is negative 2. Now, look what happens though. When I plug in negative 2, 3 times negative 2 is negative 6 plus 5. That's a negative 1. I can't have negative 1 inside a log. That was my only option, and it didn't work. So it's no solution. All right, so the first type of log equation is 1 log equals 1 log. The second type is what if you have 1 log equals a number? So I gave you directions here. I said if the equation has a logarithm on one side and a number on the other side, then condense to 1 logarithm, if you have to, and then rewrite it in exponential form. So watch this, in number 3. I have 1 log equals a number, so I'm going to go from logarithmic form to exponential form. So kind of a helpful suggestion here is when you feel stuck in your equation, you want to go from either logarithmic form to exponential, or if you have exponential, go to logarithmic and see if that helps. Okay? So again, all I did is I went from logarithmic form and I rewrote it in exponential form. Now we're going to solve. 2 to the 5th is 32. 2, 4, 8, 16, 32. Use your fingers. Use your chart. Subtracting 7, I get 25 equals 5x. Divide by 5. Don't forget to check the inside of the log. Well, 5 times 5 is 25. 25 plus 7 is 32. It's positive. That's what I need. All right, I'm going to pause, and I'm going to give you a head start. Some of you might not finish before I do, but so try 4, 5, and 6. Yeah. Sure. You can't do that. That's not true. No, this doesn't equal 5. So.
Yeah, so you
Sure. And number 4, when there's no log written, no base with log, what is the base? 10. Okay, that's called your common log. So this is 10 to the 2nd equals 5x minus 11. Log is called the common log, which means it's base 10. So this is 100 equals 5x minus 11. So I get 111 over 5 or 22.2. Either way is okay. Now check it. It does check. That gives me something positive in there. Number 5, when you have an ln, what's the base? Log e. This is log e. Sounds like I'm saying something silly. So this is e to the 4th equals 3x plus 11. What? No, ln stands for log base e.
Should you put like all of the decimals together?
I would do just a few. I actually only did one. I said 54.6 equals 3x plus 11
Yeah, I didn't know.
e to the 4. Let me grab my calculator and see if I made a mistake here.
Oh,
This is just like crazy decimal.
yeah, no, I put the log.
Oh, okay.
But e to the fourth is e to the fourth.
Okay, yeah, okay.
Basically, you don't put the log.
No, because all I'm doing is I'm rewriting from logarithmic to exponential. So when you write it exponential, there's no log
So
anymore.
don't put log in front of it.
Right. So I'm going to subtract 11, and I get 43.6 equals 3x. Dividing by 3, I got about 4.5. And I did check it. 3 times 14.5 plus 11 is positive.
She did it right.
Alright, number 6. If I want to solve ln, or that's called natural log of 4x minus 1, and notice, it matters if there's a parenthesis or not a parenthesis. Okay, that really, really matters. So this is going to be e to the third power equals 4x minus 1. Okay, so what I mean, let me kind of explain this. If the problem had looked like this, okay, this is a different problem. I would have added 1 to both sides first. Do you see that? Like, it's not that I'm being careless. If there's parentheses, it means everything's inside the log. If there's no parentheses, then that plus or minus isn't connected to the log. Alright, I got about 20.09. I added 1 and divided by 4. If I don't ask in specific, like to round 2 decimals or 3 decimals, you can round any way you want, 1, 2, or 3 places, okay? Alright, now let's flip it over. And what happens if you have more than one log on a side? We're going to make a beautiful connection to why we were doing the properties. It's like, they're actually important. They're not just to torture you. All right, so watch this. In number 7, if I have log x minus log 3, so write this in your notes above number 7 and 8. Condense if needed. Because if you have sums and differences of logarithms, you're going to need to condense it. So here's a wonderful application to that. All right, now I have a log equals a number. So I'm going to go from logarithmic form to exponential. So this is going to be a gigantic number. This is going to be 10 to the 8th equals x over 3. And you guys remember back to about maybe 5th grade, if I want to do 10 to the 8th, that's a 1 with 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. And every 3 gets a comma. So that's 100 million. So if I multiply by 3, wow, that's 300 million. You do need to check, and I hope I'm not glossing over this part, it's because I already have checked them. 300 million is positive, so that's okay. All right, I'm going to pause, and give you a short head start on 8 and 9. Condense it. It doesn't mean you always divide. Oh, did you get stuck with a quadratic? What happens with a quadratic?
No solution.
It's not no solution. No. We spent a whole chapter on quadratics. Set it equal to 0 and
Solve.
factor it. Okay?
I got the first part right.
Okay, you got the first part right. Alright, so I'll help you with 8, and then I'll let you try the next one. Okay. Alright, so here we go. You're going to condense this. The sum of two logs is the product property. Then I'm going to go from logarithmic form to exponential. So this is 36 equals x squared plus 5x. Now, when you get an equation, and this is going to help you guys, you're going to take the ACT tomorrow. So if you have an x squared, your first plan, get everything on one side equal to 0 and try to factor it. If it doesn't factor, what tool do we have in our tool belts? Quadratic formula. So you do need quadratic formula on the ACT. So I'm trying to find two numbers that'll multiply to negative 36, but add up to 5. I strongly recommend a little chart, especially for those of you that are still struggling with factoring. I mean, just because negative 3 and 12 multiplies, it doesn't mean that's my magic pair. Negative 4 times 9, ooh, that'll do it. So here we go. This will be x minus 4, x plus 9. So you set x minus 4 equal to 0 or x plus 9 equal to 0. But you have to check. 4 is okay. 4 works in both. Negative 9 does not work. It doesn't work in either of them. But if it doesn't work in one of the logs, it's not going to work. So we do know how to solve quadratic equations. We get everything on one side equal to 0. We try to factor it. If it won't factor, we have a backup plan, and it's called quadratic formula. All right, so try the next one. Try and see if you can get the whole way through. All right, did you guys get x is 16 to work? The negative 4 does not.